Hello everybody, welcome back to another edition of the Modicon M221 training. I'm your host, Leandro Mala, and in this video what we're going to see is how we can create our own function block. So let's go to the presentation. In the previous video we saw how we can create our function, okay, that has it can have too many parameters and you can only receive one output. Okay, there's going to be a result, and it can be in word, double word, or float variable real. In this case, this function block allows us to have digital inputs or digital outputs, okay, on the function block, and also we have parameters for input and output, okay, which is good. So the idea in order how to create one is the same as the other one, the function block. Just put the pen over here. Just need to go to the programming, select the user-defined function block, okay, instead of the function block, remember that one, and then we just click on this icon or right click, and then we just add the user-defined function block. Okay, simple as that. Once you add it, we are able to change the name. Okay, we right click on this one. By default is UDFB, so it's user-defined function block, and then the number of the function block that is created. If we compare this with the other one, we have some here that we have this add parameter or local variable, which is the same, but this one is new. Okay, we are able to add some functions that we have over here, that we have the same as we have in here. They are related to timers or counters. We should be able to add it over here. If I'm not wrong, I don't remember, in the previous version we don't have this part, so this is new. And in the left part we are able to see the inputs and outputs for the digital values. The digital, I mean Boolean variables. So there we go, much better. So we had the possibility to add Boolean input from this side, okay, and Boolean output is going to be the other side. Okay, so as soon as we add this, we're going to see new inputs and new outputs over here. Okay, and then we have the possibility to add the parameters that you can see, and the parameters can be parameter. Okay, there's going to be one external access to that function block that you can use it for input or for output. Okay, and then we have the variable, and the variable is like a local variable that you have in that function block. Okay, you cannot access externally, okay, directly. And then it doesn't matter if you use a parameter or variable, the type can be word, double word, or float. So it should be percentage MW, you can see it, percentage MD, or percentage MF. Okay, percentage, and percentage. Okay, so this is basically what it does. So once you create that function block, okay, imagine that you already finished. In order to get access, you just need to go to programming again, select the functions blocks that we have, and at the bottom we can see UDFB, user-defined function blocks, and here we should be able to find ours. Okay, and if you go back over here, you follow this arrow, you can find the function block name that you have, and you just click over there and then click on your run so you can add the function block. So imagine that you have, for example, by default you have one, and then you add another output. Okay, you can see this visualization. You can change the name on the input and the output. Okay, and this is the visualization on the real run. Okay, so you can see the I execute and the Q done. Okay, and here you have the instance name. Okay, this is the name of the variable, and here the instance, this 0 over here. Okay, you can see here the name, and then the 0 is the instance in this case. Okay, so this is only for the iOS, the Boolean. So if we add parameters, okay, For example, I add 3 parameters so I can access externally. So if you want to write, so it's going to be like in other software you have, for example, it should be param 0, okay, but here we don't have this possibility and we need to access externally, as we saw with the timers, the counters. So if it's this one parameter for input, we just need to define this way. We just need to define the name of the function block, the instance, dot, and the name of the parameters. In this case is param0. And then in this case, as a word type, I need to use a %NW value. Okay, now if I want an output, imagine this case is param 2, okay. In EcoStruxure Machine Expert Basic, we don't have this possibility for an analog value, so we need to access externally, as I show here at the bottom. So, depending on the variable that you have, you need to define the variable. Use this one for assignation, as you can see over here, assign. Then you need to use the instance name dot the parameter. So in this way, you are retrieving from the function block and assign that to a new variable. This is how it works, okay? So if we go to our application, just to show you quickly how it can be done, right click, add user, you can see here the name, you can double click and you can see how you can change it, okay? Blah, blah. Okay, and here you can find more information about the function block. You can add inputs, outputs, but this one is only Boolean, true or false. Okay, and as soon as you add it here, you can see the inputs and outputs. Then you have the possibility to add parameters, okay, and the parameters can be used variable. So you are using internal variables that you cannot access from outside. Then what you can do is to add function blocks. They're similar to these ones, okay? They're the same, but they have their own position. So for example, timer, I'm using a timer, add, you can see here the timer, TMA. Okay, to be honest, I never use it, okay? But you have the possibility to use it. I don't use it in here. I usually make the calculations or the process directly and use the function block to make calculations, not to make some kind of timers. The counter is in a different way. But if you want, you can do it. Probably if you are creating a lot of projects with the same, instead of having the code visible, you can use the function block, so you can copy and paste everything much easier. But in this case, I'm just going to show this part. So if you click OK, and try to use this function block in a new POU, blah blah, and select. And here you can see the parameters. As you can see here, I have param 0, param 1, but I don't have the bar 0 because it's just a local variable. Okay, that's the main difference. So once we have this, I'm going to delete it, and let's go back to the presentation. Here, so what I'm going to do now with you is to create like a linearization. In the previous video, we saw how to create a function, not a function block, with this. So we already defined this value based on the configuration, and then we have the linearization. Now what I want is I'm going to enter the minimum and the max value for the input, and then I'm going to assign the minimum and max value for the output that I want, and then make the calculation on the PLC, and then having this result, okay, for the new input. So basically we are going to make a first grade equation here. So we need 2 points from the line here to make the calculation. If we take a look, for example, in other software like EcoStruxure Machine Expert, It's not for the M221, it's for the M241, M251, M262 park drive. Okay, we have this function block. You can see here, these ones are Boolean, this one are Boolean, this one are parameters. So these ones are not, in our case, we're going to try to replicate this. It's not going to be possible. So you're going to have a block. So you can have a block with 2 inputs and 1 output. Okay. You have FB scaling or lint truffle, and the idea is the same. Okay, this is probably what it's doing in the background. So what we're going to do is to create our own function block for this. So if we go back to the software, just put this over here and open this. Okay, so we are back. So what we're going to do now is I'm going to delete this because it's going to be useless. Delete. I'm going to add a new one. Add. Here I'm going to use FB scaling for function block. What I'm going to do is to add the inputs and outputs. So let me just put in the other page what I want. So I usually use like an input like enable and an output for error, for example, in this case, just to show an error in the scaling that I want to do. Okay, now what I want is to add the parameters. So we know that we have for the linearization, if we go here, we need one minimum and one maximum for the input that I want for the scaling, and the minimum and max value for the output. So we have 4 parameters. Then we have another one for the real signal, the analog signal, and then I need 6 in total because I'm going to have the final value. So it's going to be 6 parameters. Then these are the parameters that are going to be visible. Internally, I'm going to have 2 additionals. I'm going to have the A and B for the offset and the slope. Okay, so there's going to be 6 and 2. It's going to be a total of 8. So if we go back to the here. So 1, 2, 3, 4, 5, to expand this. So in order to make it simple, because when I was doing all this part, it took me time in order to write everything. It's going to be a little bit of a mess. So what I'm going to do, instead of using this, I'm going to enter the values for the points. So it's going to be much easier to follow for me. So what I'm going to do now is to use the input x1, input x2, input y1, input y2. And then I have the input value, okay, and then I have the Q value. It's going to be the scaling. Okay, the value that is already scanned. This one's going to be the raw value. Now, what I want, as I'm going to use some calculations, I want to use float variables. So I'm going to change this everything to float. Otherwise, I'm going to have some issues if I don't use this. Float. Okay, so I have all the parameters that I want. This 5 is going to be entered into the function block, and I have only one exit. It's going to be the value. This one for analog values. Then I need 2 more. This is going to be a variable. Okay, it's going to be aux A and another value aux underscore B. Okay, so far we have defined everything that I want for this scanning. So I'm going to apply this. Now it's time to program the function block inside the function block that I have. So if I show you, let's show you this, just change a little bit the view here, and there we go. So I already create all these parameters. Okay, so this is already done. So now we need to configure this. Okay, so at the beginning I'm using the input just to execute the code. Okay, and in this case I'm comparing the inputs, the y2 and the y1 and the x2 and the x1. If they are the same, I'm going to execute the error and I'm going to finish the code, and this part is not going to be executed. Okay, so let's start by doing this. So I just need to use the address %i underscore, you can see over there, that is there. Then I need to compare, need to make the comparison here for the values. It's gonna be %i underscore, underscore i2 equal %i y1. If they are equal, then we're going to have an error. Okay, %q error, and I'm going to do the same for the x value. So x and x. Okay, and we have this one over here, end program, so it's gonna end this part. Okay, good. It's the same, but just put it in this way. Okay, so this part is just for the error. Now let's create our logic. I underscore enable. So what we need to do now is this. We need to make this calculation. So I'm going to start with the slope. Okay, to calculate the A, and once the A is calculated, we're gonna use it over here, the value, and calculate the B. So go back here and go to the program. So I have this part over here. Let me just put this the other side. So to calculate A, so it's going to be percentage aux A, 2 points, and then I need to use the percentage I y2, no, I1 minus percentage IW I y2, this divided by something similar but with the x point. Okay, I did it wrong. Why? Just check. Are incompatible. Just check what I have done here. I need to change this to float. There we go. Yes. Perfect. Now we have calculated A. So now what we need to do is to calculate B. Okay, so we can create a new run. Add it over here. I. Then calculate B. And B, if you go back over here, so the X point, first point and the other one. So now we need to calculate B. So it's gonna be like this. Let me just open the software. So it's gonna be percentage aux underscore B, 2 points equal. So I need percentage, one of the points, I underscore I2, minus the aux A multiply by the x2 point. So we have calculated A and B, and now we need to find out the value for the output. this is one way to do it. Okay, you can execute to have different inputs, so you can execute the slope and the offset and then make the calculation, so you don't need to do this all the time. So this is just one way to do it. Q underscore value. So I need to use the aux underscore a multiply by the percentage IE value plus percentage aux b. If I know wrong, this is it. So what I need to do now is to call this function block, okay, over here. And you can see all the parameters here. So I'm going to use this M0 and this one M1. Okay, so one of the things that I need to do is to read the input. So if I read the input, for example, percentage IW 0.0, I need to transfer this to a percentage NW variable. I'm going to use percentage NW 0. And then what I need to do is to convert this percentage NW 0 to a float to put this variable in our function block. Percentage NW 0. Good. And put this like this. So the other thing that we need to do is to configure these values, the points. So I'm going to add a new function here and use let's see the name, fb underscore scaling, okay, 0, remember the name, and the instance 0 dot the parameter. So it's going to be I underscore xy x1 2 percentage mf10. Okay, I'm going to copy this, paste it 3 more times. So we have all this configuration, mf2, 4, and 6. And here I'm going to use this one, x.2, x, y, and y2. So now the last thing we need to do is to show the scale value. It's going to be the output of this function block. So fb scaling 0 dot q value. So now that is ready, we can simulate this, and hopefully it's gonna be okay without error. Finger crossed. So if we want to simulate this, okay, let me just put this the other side. So if we do this, you should have the error because there is no configuration. Now we need to make the points for the scaling. So we have, for example, the input, the analog input. This one go from 0 to 1000. So the point would be from 0 to 1000. So MF 1000. So we need to check the 0 value, the 0 volts, which is the value that we want to see. In the previous video, we used these values. So I'm going to pretend that the 0 volts is going to be minus 10 degrees. So I'm going to use here minus 10 degrees. And the other one for the max value for the 10 volts is going to be 1000. I'm going to use the 38.5. Oops. 38.5. So there is no error. So as soon as we have this, we just need to enable the block. as you can see, the value, the scaling value is 10. So if we zoom in and I move from here and put it over here, we can see that we have some values. It's minus 10, minus 10. So I can play with the analog input on the other side here, so we can assign a new value. So if I go to the full scale, it's not doing nothing. Just check what's going on. Just 1 minute. Just check what is not doing anything. Bear with me a second. So, isn't it stop? No. Let me just check. Unless I'm doing something wrong here. I value multiply by this. Let's check the logic. I2 AX is working. 2 divided. Yep, it should be fine. So let's log in again. Let's see what's going on. Let's see what I have done wrong. So this value is gonna be 1000. This one, I1, it's gonna be minus 10. Minus 10. And this one is going to be 38.5. And I'm going to simulate. Yes. Now, if we see this minus 10, which is right, the other term, so we have it is the max value, and so changing the value. I know what I missed. So, wrong mistake. I have already put the value here for this percentage MF, but I never assign it to the input of the function block. So let me just put it over here. So percentage FB underscore scaling 0 dot I value. That's why it was always in 0. It happens. So now we should be able to assign the new value over there. And there we go, 3815. So let me just add a new animation table so you can see it. So it's going to be percentage MF2 and percentage 20, right? Yeah. So you can see here, value 0. And if we go to the middle, for example, like this, we have 15.511. So if we go to the calculation and use the 5 to 6, 15.5. Okay. So this is how you can use it. So basically, I create this kind of scaling that we have in this in the other software called the Machine Expert, something similar to this, but in the software for the M221. Okay, so we already replicate all this part. Yes, and the other thing optional, I haven't shown you. So imagine that you already have this software already working fine. If you want to export it and to have it in another place, in our software, in another program, on an application, you just right click over here in the function block that you have and then export. Once you export it, you can import it in the other software that you have. So this is how you can create your function block. Be aware of calling all the parameters, okay? And then you should be able to make it work fine. Okay, so this is it for the function block. Thank you very much for watching this video, and I see you on the next one.